Hello, this is Group 17's Senior Design 1 project presentation on our automated ground delivery robot. My name is Chris Maggio, and I am an electrical engineering student at SUNY New Paltz. For Senior Design 1, my role was to determine the appropriate microcontroller, motor controller, displacement sensors, and power supply for the automated ground delivery robot, and successfully implement these electronic devices into our prototype. An Arduino Mega microcontroller was selected to ensure that there would be enough ports for all the robot's current and future electronic devices. 4 sharp analog displacement sensors were selected to scan for any obstacles while the robot is traveling, and 2 L298 H-bridge motor controllers were selected to properly actuate the motors. As a safety precaution, 15 amp fuses were placed on the batteries, and 10 amp fuses were placed on the motors to protect all the electrical components. In the future, for Senior Design 2, my goals consist of continued software development for automated travel and integrating a liquid crystal display to communicate with the user.
I'm Nick Cullen, a New Paltz mechanical engineering student, and I contributed to the drivetrain and power system of the delivery robot. I performed initial calculations to find the power for proper motor sizing. The calculations showed the ground delivery robot would need about 500 watts of power to move uphill with a 50-pound package. 4 150-watt motors were selected to ensure the robot had enough power. I also worked with our electrical engineer, Chris Maggio, to implement displacement sensors and find the proper battery sizes. The batteries used in the prototype are lead-acid batteries with 8 amp hours of charge. 2 batteries were required to power all 4 motors. In the future, I plan on developing a speed sensor to allow the robot to adjust motor power as needed. Accelerometers may also be implemented as a safety feature, which will cut motor power if the robot hits something.
Hello, I'm Jordan Scocozza, and I'm in the mechanical engineering program. This semester, my job was to design an enclosure for the electrical components of the robot. The enclosure is located on a flat base attached to the bottom of the robot's frame. It sits under the main base where the package goes. The main purpose of this enclosure is to keep the electrical components fully enclosed so that they are protected from outside conditions. Therefore, the enclosure has no open space for water, dirt, or other particles to enter and potentially damage the components inside. This is important, especially because the robot is going to be traveling outside in order to make its deliveries throughout the campus. The enclosure is also useful in keeping the electrical components organized and locked in one central location. Otherwise, they may move around or even fall off the robot as it moves. The components that are inside this enclosure are the microcontroller, 2 motor controllers, 2 batteries, and the necessary wiring. This enclosure was 3D printed in PETG plastic. Next semester in Senior Design 2, I plan to implement a system for automated package disinfection and also to work on a package dispensing system.
Hello, my name is Lema. I'm a senior in the mechanical engineering program at SUNY New Paltz. My responsibilities include the design, fabrication, and finite element analysis of the robot's outer frame. Key design objectives completed throughout this semester include modeling the frame in SolidWorks, accounting for tolerancing within the 3D printed components, and properly selecting the necessary materials used in the robot's fabrication. Analysis into the mechanical nature of the frame was conducted via ANSYS and SolidWorks. By approximating load values placed on the frame based on the weight of the frame, package, and other electromechanical components, it was possible to obtain stress, strain, and deformation data on the frame assembly. Further analysis was conducted on a crash load and an estimated maximum possible load placed on the base of the robot. Future goals include heat analysis of the system within SolidWorks and ANSYS, implementing fully autonomous movement from one point to another by mapping out a route within SUNY New Paltz, and designing a locking mechanism to secure the package onto the base of the robot.
Hello, my name is David Betolatti, and I am a mechanical engineering student. My portion of this project revolved around the wheel and motor assembly along with the 3D printing of various parts. For the wheels, I did not want something with too large of a diameter because that would make the motors require more power to move the robot. If the wheel diameter was too small, the robot would have the chance of bottoming out. I decided to go with 6-inch diameter wheels with solid rubber tread. The solid rubber provides good traction and since no air is needed in the tires, they are maintenance-free. The 6-inch diameter allows the robot to have at least an inch of ground clearance, which is plenty for its designed use. The motor mounts I made were designed in SolidWorks and then 3D printed. The goal of the motor mount design is to keep the motor far under the chassis and the wheel as close to the side of the chassis as possible. By doing this, we are keeping the bending moment applied to the motor mounts as low as possible, therefore increasing the longevity of the motor mount. We would like to finish this presentation with a short demonstration of our functioning prototype. Before we do that, though, Group 17 would like to thank you for your time, and we look forward to seeing you in May at the Senior Design 2 Engineering Expo.